All right, let's take a look at this problem here. So Diego, Lynn, Mai went to the ticket booth to the bumper cars. So complete the table. Diego left the ticket booth at the same time as Tyler. Okay, seems like pretty important. So I'm gonna highlight that. So Diego left at the same time as Tyler. And then Diego jogged ahead at a steady pace and Diego reached the bumper cars in 30 seconds. Okay. Okay. Well, let's take a look. Then it took the same time. I mean, it would be 0, right? Like he didn't go anywhere. At 0 seconds, he didn't go anywhere. So let's take a look. We got 50 and 30. So it's going to be 50 meters. 50 meters over 30 seconds. 30 seconds. What I can do is I can write this into an equation if I would like. I can write y is equal to 50 over 30 x, and that's representing my meters. Remember, that's my y, and that's my x, the denominator x, and that's meters, and that represents my seconds. So let's do y is equal to 50 over 30x. And this red right here is my constant of proportionality, which goes right there. All right, well, Diego's time in seconds, we're given that. So we're gonna do 15 seconds, right? So we're gonna plug in 15 here. So 15 seconds, so it's gonna be y is equal to 50 over 30 times 15. And that is going to be 50 over 30 times 15 over 1, because we can put that into a fraction, and do 50 times 15. 50 times 15. 50 times 15 is going to be 750. Y is equal to 750 over 30. And 750 divided by 30. 750 divided by 30 is 25. So y is equal to 25. And the y represents meters, right? Y represents meters. And so y is equal to 25 meters. So 25 meters. Okay. And how about the 1, right? 1 after 1 second. Well, we got 50 meters per 30 seconds, like we got right here, like what we got here. And we're going to divide it by 30, like orange for the dividing. Divide 30 and divide 30. And that's going to be is equal to 50 divided by 30. 50 divided by 30. 50 divided by 30 is 1.6666. Or if you like if you don't like the long fraction, you could actually just go like this. You can do what I'm gonna do is I'm gonna divide this by 10. And divide this by 10. So what I'm gonna get is 50 divided by 10 is just 5. And then 30 divided by 10 is just 3. So that's the simplest form it can go. Meters over second. But that is the same thing as 5 over 3 meters per second, right? You see this fraction? I just broke it down. 5 over 3 meter per second. But this meter per second, I just made it like that. I just made it look like that. So what this is saying, it's 5 over 3 meters per second, and that's equivalent or approximately like 1.666, so on and so forth. 66666 forever. Meters per second. So the answer here, 5 over 3 meters per second, right? Or 5 over 3, yeah. And the reason why it's 5 over 3 is 5 over 3 meters per 1 second, because this, even though there's no number in front of it, it's actually saying 1 second. So it's actually saying it's 5 over 3 meters per 1 second. So that is that for this one. Okay, let's go to the next one. let's go to this one. And I think this one's going to be a little bit easier in terms of numbers. So I'm going to do 50 over 20. So 50 meters over 20 seconds, right? And let's just keep it simple. I think this is going to be 0 to 0, right? Because when you didn't travel any, you're going to just have 0. So I'm given 50 meters, right? 50 meters for 20 seconds. It seems like this piece of information is pretty important, right? That's a given. And then I gotta use that information to draw that right there. And if I simplify this and I divide the top by 20 and the bottom by 20, that's gonna give me my constant of proportionality, which is gonna be 20 divided by 20, it's just 1, right? 1 second. And 50 divided by 20. 50 divided by 20 is 2.5. So it'll be 2.5 meters. So every 1 second, she travels 2.5 meters. So automatically, I know that she travels faster than this guy, faster than Lynn, right? Or faster than Diego, because 5 over 3 is just 1.66 meters, right? So every second, Lynn travels 2.5 meters. And this is important because this right here, once again, everybody, is the constant of proportion. That's the constant of proportionality, everyone. Wow, this circle thing is kind of crazy. That right there is the constant. All right, one last time. That is the constant of proportionality, and so is this one, right? When x is 1, that y represents the constant of proportionality, which I think is pretty cool. And this one too. Let's go use this one here, and we gotta find this one. So if Lynn travels 25 meters, right? 25 meters. Then what is that? So I can do several ways, but I'm just gonna do it this way because it seems the easiest. So it's gonna be 20 seconds, right? So how do I get 25 meters from 50? I just divide by 2. Divided by 2, divided by 2, and then 50 divided by 2 is 25 meters, and 20 divided by 2 is 10 seconds. So 25 meters is 10 seconds. So let's take a look at this problem right here, right? And for Mai, she leaves 10 seconds later than Tyler. So it means that in the beginning, before we start counting her meters, we actually have to say that she started 10 seconds before that. So that's actually something that we have to be careful about, because for all of these ones, we started at 0 seconds, 0 seconds, right? And I think the reason why is because even though it doesn't say right here, Tyler starts at 0 minutes and at 0 meters and at 0 meters and at 0 meters. And I don't know why the problem doesn't talk about that, but that's what it is. So then let's take a look, right? So this is something that we haven't really learned about, but it is something for us to discuss right now. Okay, so if you take a look, we can't actually start at 0, right? Because like I said, it's not start at 0. So what we're gonna do is we're gonna say from 10. So that's at 10 seconds, right? 10 seconds, and then she traveled 0 meters, right? So for 10 seconds, she didn't move. And then after 40 seconds, she traveled 50 meters. So after 40 seconds, she traveled 50 meters. So what that means is that she's actually traveled 30 seconds and actually traveled 50 meters. Okay, so from from 10 seconds to 40 seconds, how much time has passed? 30 seconds has passed. And how much distance did she cover? She covered 50. So we have to actually write the, this isn't actually called constant of proportionality in this scenario, and it's actually called slope, but you'll learn about that later. So 50 meters per 30 seconds, right? Which means the same thing as this one is equal to 5 over 3 meters per second, which is equal to 5 over 3 meters per second, which is equal to 5/3 meters per second. And that is the same thing as what we had right here, 5/3 meters. So my answer for this one is 5/3 after 1 second. Actually, after 1 second is still 0, right? After 1 second is still 0 because she hasn't gone anywhere. For 10 seconds, she's still at 0. So she's just standing there, right? So she left the booth 10 seconds later than Tyler. So she just stayed at the booth for 10 seconds. So after 1 second, it's going to be 0 because for 10 seconds, she didn't move anywhere. So then from here, from 10 to 40, how much time has passed? 30 seconds has passed, right? And so then we have to figure out how much 30 seconds, how much time has passed if traveled from 0 to 25 meters, right? So let's take a look. From 0 to 25 meters, it's going to take her, so that's 5 meters, 5 meters per 3 seconds, 3 seconds. So after 5 meters, that's the unit rate or the constant proportionality that we got here. And then for meters is 25, right? So I'm going to multiply times 5 on the numerator and times 5 on the denominator. And that is going to be 5 times 5 is 25 meters over 3 times 5, which is 15 seconds, right? So to travel from 0 to 25 meters, to 25 meters, it took her 15 seconds, but we can't start at 0. We started from 10 seconds. So we actually have to add the 15 seconds here plus 15, which is going to give me 25 seconds. That part was really, really difficult. So if you didn't get that last part, Mai's time, that's okay. We'll cover that more in our linear equation. You probably won't learn this again until like 8th grade. So don't worry too much about Mai's. Yeah, please don't worry about Mai's. Okay. All right, let's keep going. And that is it. And then I'll cover the next video. Okay, bye.